Linear motion. What is motion? Motion is the free movement of a body with respect to time. It can be defined as a process of changing the position. For example, a moving train, a rotating fan, a ball rolling around, etc. There are different types of motions in physics. With respect to the nature of movement, motion is mainly categorized into 4 different types. 1. Linear motion. This motion is a one-dimensional motion that takes place in a straight line. For example, a train running on a linear track. 2. Rotatory motion. This is a kind of motion in which the object rotates around a fixed axis. For example, a rotating fan. Oscillatory motion. In oscillatory motion, an object repeats in the same motion continuously back and forth. For example, a pendulum. 4. Reciprocating motion. This motion is a continuous up and down or back and forth motion. For example, a gymnast swinging on a ring. Today our topic is the linear motion. Linear motion meaning the change of position of an object with respect to time interval. Motion is described in terms of the following terms: distance, displacement, speed, velocity, acceleration, and time. I separated these physical quantities to 2 groups. Because in the left side group, there are scalars and in right side, vectors. First of all, we can start from the distance. What is meant by distance? Distance refers to the total movement of an object without any regard to direction. Measured in meters. Distance is the measure of how much ground an object has covered during its motion. It is the actual length of the body is moving. In this example, you can see the path of actual length moving object moves. In physics, displacement indicates a simple s. Displacement is defined as the change in the position of an object. Measured in meters. Displacement refers to the measure of how far displaced of an object. Displacement equals to the least distance between the starting point and the end point of the moving object. Examples. These are the major differences of distance and displacement. The boy in the mountain bicycle moves A to C from B on the pink-colored road. His distance is 7 meters and displacement is 6 meters. Displacement direction is purple-colored line and angled A to east side. Remember, when indicating a vector, include the direction. In this example, the boy's distance of ABCDA road is 16 meters and displacement 0. This is the summary of difference between distance and displacement. Pause the video. Read the tables and understand the difference. Let's move to the next step. Speed and velocity. Speed. Speed is the rate of change of distance moved with time. The unit is meters per seconds, and alternatively the practical units are kilometers per hour. It is a scalar quantity. Speed equals distance over time. Speed is varying every time in real-world conditions. So, we can calculate the average value. Average speed. Average speed is the total distance traveled divided by the total time taken. The average speed is a better representation of the motion of a body that not moving at a constant or uniform speed. It gives an idea about a non-uniform motion. I can give a real-world example. At the exit of a highway or a motorway, we receive a bill. In the bill, you can see our speed in the motorway. It is a kind of average speed. It calculated from our total distance divided from the spent time in the motorway. This is a theoretical question. Calculate the average speed. You have an example. Calculate the average velocity. A car covers a distance of 60 kilometers in half an hour. What is the average speed of the car in kilometer per hour? Solution. Time equals half an hour equals 0.5 hours. Average speed equals total distance covered into total time taken. 0.600 divided from 5 equals 120 kilometers per hour. It means this car has different velocities with the time. But we can calculate the average velocity. Average velocity gives an idea about the motion. This is a very valuable topic, and you have more advanced examples in the motion equations video. Above card link. Velocity. It is the rate of change of displacement with time. The units are meters per seconds. It is a vector quantity. Velocity equals displacement over time. Let's discuss more about velocity. Uniform velocity. It is obtained. The rate of change of displacement with time is constant. When a body travels equal directional displacements in equal time intervals, it is a uniform motion. In this example, rectangular body moves equal displacements in all 1 second time periods. So that body has a uniform velocity. I can suggest a practical example. Imagine the vehicle speedometer. When we go vehicle on a linear road, we can stay placed the speedometer pointer at a same point from keeping the accelerator. In this time period, our motion is a uniform velocity motion. This example, it is 31 kilometers per hour. We can indicate this motion in a velocity time graph. The velocity is same during the whole time period, and the slope of the graph is 0. Instantaneous velocity. It is the actual speed of a body at any instant point during the course of motion. Every linearly moving object has an instant velocity. It can divide into the speed and the direction. In practical experience from a vehicle, we can feel the speed of the vehicle. As well as a vehicle changes its speed and the direction quickly. In this example, you can see the direction of the object is changing every second, so that it has various instantaneous velocities. You can see the directions of this various instantaneous velocities. Acceleration. An object that is moving in a straight line will be accelerating if its velocity is increasing or decreasing during a given period of time. The definition of acceleration is velocity difference over time. Acceleration can be either positive or negative depending on whether the velocity is increasing or decreasing. A vehicle's motion can help to explain the linear acceleration. The speedometer in the vehicle measures the velocity. Uniform acceleration. When the rate of change of velocity with time is constant. It is a uniform acceleration. In this example, body increases the velocity every second 10 meters per second. So that the uniform acceleration is 10 meters per square seconds. We can indicate this motion in a velocity time graph. The slope equals to the acceleration, and uniform acceleration motion has a constant at graph slope. You can know more about velocity time graphs from above card link. Listen carefully. If a body is changing the position with time, it has a displacement. If the changing of the unit time displacement is constant, the velocity is constant. If the velocity is increasing with the time, body has an acceleration. If the object acceleration is increasing with time, the parameter has not a proper name. We call it non-uniform acceleration. Now we are in the last part of the lesson. Non-uniform accelerations. Two types of non-uniform accelerations. Increasing acceleration and decreasing acceleration. Consider the object. has following instantaneous velocities in 1-second time periods. You can see the velocity is increasing with time. But increasing is not uniform. In first time period acceleration is 10. In second it is 11. As well as the acceleration increasing quantity is 1. Do not think too much. This is an advanced mechanics problem. A body's acceleration will be the final result due to all the forces being applied to the body. We also describe it by Newton's second law. Acceleration is a vector quantity that is described as the frequency at which the object's velocity changes. This is the end of the video. Subscribe the channel and enjoy more videos about science.